Well, hey, seventh graders. I hope you enjoyed the experiment with the color changing liquids. I thought maybe you might like to see how that actually worked. I think by now you've probably figured out that there's no such thing as magic. That's why we're learning about science. Magic means that somebody like me might have special powers and I can break the laws of nature. Or it might mean that you can go to a certain place and have special magic powers when you go there. And these powers have no explanation. But science isn't like that. Science means there's always a reason behind everything. And the reason has something to do with the laws of nature or the laws of physics. And of course this experiment did too. In this demonstration, as you might guess, I bet a lot of you guessed, I had done a little setup ahead of time and prepared the experiment. So I'm going to show you how I did that and show you how this worked. If you don't like knowing how magic tricks work, don't watch. First of all, I needed some cups. I had 7 cups, I believe. And these are empty, dry cups, nothing in these. I also had a styrofoam cup. Here's my styrofoam cup. And I had a jar, a pitcher, jar, anything like that could work. But I also had some chemicals. This demonstration actually is a chemistry demonstration. It shows the reaction of 2 kinds of chemicals, something called an acid and something called a base. And when acids and bases mix, sometimes interesting things happen. I also used a couple of chemicals which are called indicator solutions. An indicator solution will indicate or show whether something is an acid or a base. For instance, lemon juice is an acid. If I put this indicator solution in lemon juice, this clear liquid would change to a different color. Milk is a base. If I put one of my indicator solutions in milk, the clear liquid would change color. So I'll show you how I set this up. I used eyedroppers and I started with my jar, and my jar is going to have a very strong base, and this clear liquid is ammonia that we use for cleaning things. And I put about 3 pipettes full of ammonia in there, down in the bottom. And you probably wouldn't even notice it was there, except that my ammonia has a little bit of soap in it, and so you might have seen a little bit of soap suds. You can buy ammonia without soap in it, but I didn't have any. Then I had my cups I had to prepare. The first cup, I left it empty. Second cup, I put in a liquid called phenolphthalein. It's a clear liquid. And phenolphthalein, if it touches a base, will turn red. My third cup had a liquid called thymolphthalein. This is another clear indicator, but if it touches a base, it turns blue. My fourth cup was empty. And then my fifth cup had phenolphthalein, so it should turn red. And my sixth cup had thymolphthalein, so it should turn blue. And the 7th cup had something different. The 7th cup had an acid, and the acid is one you probably have at your house. It's called acetic acid, also known as vinegar. Now it takes a little bit more of that. If you were here in the classroom when I did this, you might even notice there's a little bit of liquid in the bottom. Of course, vinegar is clear also, but it's an acid. Everything is all set up. Put my empty cups back upright. And here's my pitcher. Remember, it has some ammonia in it, which is a base. And I started by putting some water in the pitcher. and then I simply started pouring. First cup empty. Second cup phenolphthalein. Third cup thymolphthalein. Empty cup. Phenolphthalein. Thymolphthalein. And vinegar is an acid. When vinegar touches ammonia, there's no color change. It's just a mixture of vinegar and ammonia. Then I poured all the containers back into my jar. The last one is the key. So the first 6 cups just mix together. And it makes purple color. And now that brings us to the last cup. Remember, the last cup has some vinegar in it. When I pour the vinegar into all of this purple liquid, the vinegar takes away the color. And I'm a little short of vinegar there, so let's just add a little more. And there we go. The vinegar takes away the color. So that was the first part of the experiment. The second part was when I made the liquid disappear, if you remember that. Remember, I had a styrofoam cup, and the styrofoam cup had something in it too. This powder is called sodium polyacrylate. It's a powder you've all used before, but probably not since you were very young, because this is the powder that is put in disposable baby diapers. It's super absorbent powder. Every little particle is like a little tiny sponge. And any liquid that gets poured into this, any liquid at all, is going to get soaked up by that powder, so that when I pour it in, and I wait just a few seconds, there it is. It's still in the cup. Here's what it looks like. There's my water. It's clear because that's what color it was coming out of here. If I had pink or purple or blue water in here, it would be that color. This is not edible. It looks kind of like it's frozen, but it actually is the same temperature of the liquid. And this is what's inside a baby diaper after it's been used, except that this stuff would be a little bit yellow. I hope you enjoyed the experiment. Let's see if we can find some other examples of magical things in nature. And I want to point out to you something very important that you're going to learn this year. I love this quote from the great scientist Michael Faraday. I want you to think about how this applies. Michael Faraday said, "Nothing is too wonderful to be true if it be consistent with the laws of nature."